Welcome back, folks, to another session of mathematics, that is Euclidean geometry. My next theorem is going to be similarity. According to South African syllabi, similarity starts from grade 9 and it goes to grade 12. Now, what I'm going to do two things. I'm going to be proving the theorem, which is very important. I'm going to be stating the theorem, which is very important. When we state the theorem, make it a point that you understand, because when we prove, we shall be proving what we have stated. Now, let's look at the theorem itself. Similarity, which is denoted by this symbol. Let me move over. Two triangles or more are similar if they meet two conditions. One, their corresponding angles must be equal. By corresponding angles, let me refer you to those two triangles. Angle A corresponds with angle D. Angle B corresponds with angle E. And angle C corresponds with angle F. Now the theorem says for them to be similar, their corresponding angles must be equal. Number two, for these two triangles to be similar, their corresponding sides are in the same proportion, or must be in the same proportion. What are we talking about? When you divide AB by DE, remember now, DE corresponds with AB. You must get the same answer as when you divide AC by DF. Also, your answer must be the same as BC divided by EF. Then you know that now those sides, the corresponding sides, are in the same proportion. Therefore, the two triangles will be similar. How do we prove this theorem? We will give you two triangles, triangle ABC and triangle DEF, with angle A equals to angle D. I will go and mark there. It says angle A is equals to angle D. I mark them with the same symbol. Angle B is equals to angle E. Let's use this one. Angle B is equals to angle E. It is given to us. And lastly, angle C is equals to angle F. Let's use another color. Angle C is equals to angle F. Now, what is it that we are required to prove? We are required to prove what the theorem states, that the two triangles are similar, and therefore, if they are similar, AB divided by DE is exactly the same as AC divided by DF. How does this proof goes about? First thing, it is going to be construction. My construction, I'm going to draw line GH such that, this is very important, such that AG is exactly the same as DE, and such that AH is exactly the same as DF. Now let's do that, folks, and see what happens. My construction, I draw this line. And remember, I said it was GH. Therefore, point G would be on AP, point H would be on AC. What did we say there? We said AG must be the same as DE. I'm going to mark this and that equal. Then AH must be the same as DF. And very important, this is from our own construction. Now from there, what is it that we can see from our construction? If you look at that construction, it has brought back a theorem that we have done in grade 9, 10, and 11. What is that theorem? It is congruency. You look at this triangle, AGH. AG is exactly the same as DE according to our construction. AH is exactly the same as DF according to our construction again. And moreover, we were given that this angle is equals to that angle. That means now, the first part of the proof, I'm going to use congruency. Let's prove it. What I know is AG is equals to DE. How do I know this? It is from my construction. I'm going to write the construction. Then I also know that angle A is equals to angle D. How do I know this? It was given in my statement. That is why I'm going to say given, because the information was provided. Next, I know that this side is equals to that side. That is, AH is exactly the same as DF. How do I know that? There it is from my construction. That is why I'm going to say construction. Now, from these three statements, I can conclude that, therefore, triangle AGH is now congruent to triangle, sorry about that, DEF. Why are the two triangles congruent? Coming up with a reason. The two triangles are congruent because this side is equals to that side. That is why I'm going to put side there. This angle is equals to that angle there. And lastly, this side is equals to that side. That is, side included angle side is exactly the same as side included angle side in that particular triangle. Now, why am I proving the two triangles to be congruent? Why must I do that? The reason is simple and beautiful. I'm proving these two triangles, triangle AGH, to be congruent to triangle DEF, which they are according to the conditions for congruency, so that I can say the remaining corresponding components are also equal. What does that mean now? The remaining corresponding components, I now mean that this means the fact that this angle is now equals to that angle. Let's write it down. Let's say this is angle G1. Angle G1 is exactly the same as angle E. How do we know that? It is because of what we have just proved, which is so powerful, congruency. I can now say from this, remaining corresponding components are also equal, of which I can also say angle H1 is exactly the same as angle F. I want you to note that I use the same color for equal angles. Now, I'm going to write the angle H1 is equals to angle F. It is also from congruency. Now, first part was congruency. Using congruency to decide that corresponding remaining components are equal. Now, if you look at this, remember that we were told that angle B is equals to angle E. I'm going to put that down. Angle B was said to be equals to angle E. It was given to us. Look at what we have done now. We have proved that G1 is equals to angle E. Angle G1 is also equals to angle E. I will say proved. Then from these two, I can now see that both angles, each one of them is equals to angle E. That is why I am going to say, therefore, angle B is equals to angle G1. Now, this means that this angle is equals to this angle. If you look at the shape that they form that shape. I have said that angle is equals to that according to our proof. Now, what can we conclude about the two lines because of that? I can conclude that this line is parallel to that. That is why I'm gonna say this means GH is, parallel to BC. Why are the two lines parallel? Because I can see that corresponding angles are equal. I want to repeat this again. I was told that angle B is equals to angle E, but now from my congruence here, I have proved that angle G1 is also equals to angle E. Angle G1 is also equals to angle E. Angle B is equals to angle E. The G1 and E was from congruency. Now, this means that angle B, which is this angle, is equals to angle G1 because both of them are equals to angle E. Now from there, I can conclude that this side is parallel to that side because we can see that corresponding angles are equal. Remember, what is it that we want to prove? We want to prove that AB divided by DE is equals to AC divided by DF, which are corresponding sides of the two triangles. Now I'm going to remove this so that we get the space to write. Finish off this beautiful theorem. Now from here, remember the previous theorem. A line drawn parallel to one side of the triangle divides the other two sides in the same proportion. Now it means from the previous theorem, I can therefore say side AB, which is this, divided by AG. I'm taking AB, I'm dividing it by AG, is in the same proportion as AC. There's AC divided by AH. Now, this is gonna be from proportionality theorem, where GH is parallel to BC. I repeat again, it is from proportionality, which is the previous theorem that we have proved. But now, let's look at this, folks. AB is divided by AG, but according to the theorem, they want us to prove that AB divided by DE is AC divided by DF, not this and that. Now I'm going to circle what we don't want here. How are we going to get rid of this? We are not going to take the T-pex and T-pex it. We use mathematics. Remember, from the construction, we said that AG was equals to DE. That is from the construction. And we also said AH must be drawn equals to DF. Now, what can we see here? A beautiful thing. There we have this, and there we have him. Now, if this is the same as this, which is that, it means that I can replace this by that. Let's do that. Therefore, beautifully, AB divided by DE is now the same as AC divided by DF. We have proved the theorem that states that two or more triangles are similar provided their corresponding angles are equal and the corresponding sides are in the same proportion. Folks, go to our page and like this and make it sure that you follow it as it is. Make sure that you understand it so that when we apply, you are able to follow and apply it correctly. Thank you.